Apple Pay, Security Technology Investigation. A few years ago, users of internet services began to realize that when an online service is free, you are not the customer. You are the product. But at Apple, we believe a great customer experience should not come at the expense of your privacy. On September 9, 2014, Apple Incorporated made their company debut into the payment processing sector with their announcement of Apple Pay, a new contactless payment. The primary goal of Apple Pay is to provide a faster, easier, and more secure transaction. Apple's approach into mobile payments consisted of integrating a revised version of Apple Passbook with Apple's Touch ID. In essence, Apple's initial entrance into the payment processing sector began in 2012, with the launch of Passbook. Apple Passbook provided users with the capabilities to store gift cards electronically, intended for the purpose of in-store transactions. Apple Pay has extended user capabilities to now also store credit cards, as well as extending to a versatile application, by which can also be used for e-commerce transactions. The operations of Apple Pay include a user request to initiate the use of a new payment card. New cards may be added to the device by scanning the card with Apple's EyeSight camera or manually entering the information. If accepted, the payment card will be updated to Apple Passbook. As a security measure, the original payment card number is not visible. Instead, a substituted version is presented for user access. The user can authorize the transaction by verifying their identity using the device's biometric fingerprint sensor, known as the Touch ID. Each purchase will be stored in Passbook under recent purchases. For e-commerce transactions, the process is similar. A user may select Apple Pay as the payment method on any participating online e-commerce website. Next, authorization of the transaction is completed by the Apple Touch ID. An establishment of extensive network partnerships is the critical key to driving Apple Pay to the top of the payment industry. At this time, Apple maintains business connections with 84% of banks within the U.S. and established relationships with over 220,000 merchants. Additionally, Apple has obtained business affiliations with major credit card companies. As a result of the collaboration between Apple and each separate entity, Apple conveys a competitive edge to the payment processing sector. Apple's digital payment service has surpassed their competitors and exceeded the expectations of consumers by providing a service that offers contactless near-field communication payments, biometric securities, tokenization, EMV standards, secured storage, and the extensive encryption of sensitive data. Overall, these innovative improvements provide Apple with a competitive advantage in the market, while supplying the highly demanded data security to their users and business partners. The main purpose of implementing information security consists of minimizing vulnerabilities, protecting sensitive data, and planning control strategies in the event of a security breach. The primary focus in regards to the data security within Apple Pay's system is surrounded by a process known as tokenization. Tokenization is defined as a course of action by which sensitive data is substituted with an encrypted code, known as the token. Apple Pay follows the principles of an EMV payment tokenization structure. EMVCO is a company established in 1999 and founded by Europay, MasterCard, and Visa. EMVCO was developed to create payment conditions and specifications. One of the many reasons why Apple has incorporated NFC technologies is to reduce any redundant processes that possibly could have been avoided altogether, processes by which may have previously been unnecessary and time-consuming, such as scanning barcodes or entering a PIN during the payment transaction. NFC technology is essentially used as a tool by which provides a short-distance, contactless, and wireless connectivity to a specific network. The overall structure of Apple Pay's EMV tokenization is divided into two distinct processes, the registration process followed by the payment process. As the token requester, Apple forwards the token request via Apple's own proprietary software. The token will be verified by the payment card network. In turn, the request will then be sent to the issuing processor. The issuer finalizes the registration process by providing a unique payment token number to Apple. At this point, the encrypted token is securely stored within the secure element of the mobile device. Apple does not store encrypted data remotely or within iCloud. Instead, they store sensitive data, such as the encrypted token number, within the hardware of the device. It is stored by a secured element, also known as the secure enclave, which is located inside the A7 chip. Due to the fact sensitive data is unknown to Apple, as well as inaccessible to any other system components, it creates an additional layer of security for the user by restricting the accessibility of sensitive data. If the system was compromised, the encrypted token would not be useful or valuable to any potential attacker or data thief. Next, the application is able to be utilized for making a payment. This activity takes place in the payment process of the tokenization structure. For an in-store transaction, the point-of-sale flow begins with the transfer of payment token data components from an NFC-enabled mobile device to an NFC-enabled terminal. Each contactless data element, including the payment token, token expiration date, token cryptogram, and the token requester ID, will be transmitted to the merchant terminal. Similar to the payment token, the token expiration date takes place of the true pound expiration date. The token cryptogram is used as a validation tool to authorize the token. The token requester ID is an optional data element, and can be used as an alternative verification method. This method solely identifies and confirms a token's authenticity. Next, the contactless authorization request will be transferred to the acquirer. The authorization request will operate on the entry mode of a POS system, and will contain the previously defined data elements. Once the token and associated data is received by the acquirer, a customary processing, verification, and confirmation method is finalized. The acquirer will use an identical process to a standard transaction. According to the EMV payment tokenization specification, the acquiring process includes authorization, capture, clearing, and exception processing. The next phase of the mobile NFC point-of-sale flow consists of an interface between the payment network and the token service provider. The token service providers of Apple Pay's current business agreement additionally take on a further role as the partners of the payment network. This interface is used to oversee and secure the token vault. The EMV payment tokenization specification and technical framework defines a token vault as a repository implemented by a tokenization system that maintains the established payment token to PAN mapping. After the payment networks confirm a token's true authenticity, they complete the decryption of the payment token and PAN expiration date. The network then will forward an updated authorization request to the issuer. The decryption process is completed by interchaining a payment token to the original PAN and replacing the token expiration date with a PAN expiration date. The updated authorization request contains the payment token, token expiration date, token assurance data, the token assurance level, a token requester ID, and the POS entry mode code. The token service level is established by the identification and verification ID and V results, the location of the token, and the related entities. ID and V determines an assurance level for the payment token to PAN conversion. Common methods of ID and V include account verification messages, risk score assessments, and one-time use passwords. The POS entry modes were established to limit a particular transaction. For example, Apple is recognized as the payment token requester, therefore, Apple is primarily responsible for determining the limitations of the POS entry modes. After the transmission of the revised authorization request from the payment network to the issuer, the account-level validation and authorization check is finalized by the related issuer. The card issuers partnered with Apple includes First Data, TSYS American Express, Capital One Bank, JP Morgan Chase, Citi, and Wells Fargo. The issuer directs the PAN back to the payment network. The original authorization request would now be altered into a new form of data known as the authorization response. Once the authorization response is received by the payment network, the PAN is transformed back to an encrypted token number. Next, the authorization response is sent back to the acquirer. The final responsibility of the acquirer is to forward the payment status back to the merchant. All of the participating entities, the typical data flow, and tokenization process overview is denoted in Figure 1. Figure 1 was initially presented in Section 9.2 of the EMV Company Framework publication. Overall, the EMV tokenization process communicates sensitive data from an NFC-enabled mobile device to the merchant to the acquirer to the token service provider and payment network interface, and then finally from the payment network to the card issuer. Once the data is received by the issuer, the data flow process will work in reverse by sending the data back through each entity until it reaches the original requester. By limiting the access of this sensitive data, Apple provided further security. Entirely as a company, Apple does not store any payment information. Additionally, the encrypted token is only stored between the hardware of an NFC-enabled mobile device and a token vault, which is secured by the token service provider. On July 27, 2012, Apple Incorporated purchased Authentech for $356 million. Authentech is a mobile security firm that specializes in fingerprint and sensor technologies. Apple's Touch ID software is a biometric fingerprint sensor technology. The Touch ID was designed to complete a verification of user identity. This feature was implemented in lieu of a standard password-protected application. Apple launched the Touch ID biometric feature as an additional data security procedure intended to also be used during the payment process. As previously stated, the iPhone uses the Secure Enclave as storage for sensitive data. Once the technologies within the secure enclave establish if the fingerprint is a match, it completes the transaction. This feature may also be used to unlock the iPhone's home screen. Similar to the storage method of an encrypted token, biometrics data is secured within the A7 chip inside the secured enclave. Essentially, the A7 chip is used to transfer information from the Touch ID sensor to the secure enclave. The A7 chip does not have access to this data. Once the data is received by the secure enclave, the device uses a shared key to process the encrypted fingerprint data. According to Randy Vanderhoof, director of the EMV Migration Forum and the executive director of Smart Card Alliance, Apple has raised the bar on security with using biometrics for user verification. User convenience creates fast and easy payments, by which are processed within real time, and provide a suitable substitution for an actual payment card number. Due to the capabilities of near-field communications technologies, Apple Pay offers a context-aware approach that enables automatic access to the passbook application, while nearby an NFC-enabled POS system. An additional advantage consists of cost savings. Banks can reduce costs pertaining to new card issuing and card replacements. This feature will also allow any card replacement to be done instantly. Furthermore, the new EMV tokenization system minimizes payment card data exposure. With the use of tokenization and Apple's fingerprint biometric feature, Touch ID, Apple Pay has created a unique product that surpasses their competitors in both the payment and technology industries. However, Forrester analysts suggest this innovative model will trigger an inflection point in the evolution of mobile payments and inspire competitors to rise to the occasion. Due to the quick and aggressive response of their competitors, in order to succeed, Apple Pay relies on a wide variety of networks. Apple will have to acquire relationships with additional merchants, as well as maintain their current partnerships. A possible reason that a merchant may be hesitant to accept Apple Pay would be the potential conflict of integrating Apple Pay with the merchant's current tokenization system and the new limits and restrictions of customer data. If the merchants are no longer granted access to this information, it will impact their current refund processes and eliminate the ability to view customer purchasing patterns and customer profiles. Also, the acceptance of Apple Pay may affect the current return processes, POS setups, and will require NFC-enabled headsets. Similar to the merchants, the banks may have a few concerns regarding the implementation of Apple Pay. When a financial institution signs on and agrees to create a partnership with Apple Pay, they are also agreeing to the use of Apple's Touch ID as security device. If the financial institutions are publicly agreeing to use Apple's software, it displays acceptance of the Touch ID as a primary access mechanism to a consumer's digital identity. This causes the banks to be at risk of losing the important position and responsibility to act as the gatekeeper for their customers' digital identities. As previously stated, Apple's digital payment service has surpassed their competitors and exceeded expectations by providing a service that offers NFC payments, biometric securities, tokenization, EMV standards, secured storage, and the extensive encryption of sensitive data. As a final point, Apple is committed to maintaining their application with ultimate security features and is dedicated to a guaranteed protection and security of each and every one of their users' confidential data. According to Tim Cook, I want to be absolutely clear that we have never worked with any government agency from any country to create a backdoor in any of our products or services. We have also never allowed access to our servers. And we never will.